Okay guys, the chapter that we're discussing today is functions. Now first of all, it is important to understand the concept of function and visually try to visually conceptualize the concept of function. And this is what a function is. You can understand a function as a machine. You can understand a function as a machine which takes some input and gives some output, right? It is a machine which gives you some input and which takes some input and gives you an output, right? Say for example, a function is denoted by the symbol f. So this is fx, means it is a function of x. That is, x is the variable in this function. So let's say, let me take a function 2x plus 1, right? A simple function with two terms. So function is 2x plus 1. Here x is the input. X is the value that we are going to put in this machine, in this function, and we'll get the value of the entire function as fx, right? So we can draw a table to see what all values are input, what all values are output. So let's say if we take the value of x as 0, right? So let's make a chart for x and y where y is equal to fx. If we put x is equal to 0, then what value of fx will we get? 2 into 0 plus 1, that is 3. Sorry, that is 1, right? So 2 into 0 is 0 plus 1 is 1. Okay, if we take x is equal to 1, then 2 into 1 plus 1 would be 3. If we take x is equal to minus 1, then 2 into minus 1 is minus 2 plus 1 is minus 1. If we take x is equal to 2, 2 into 2 4 plus 1 5. See, we're taking different values of x and we're getting different values of y or fx. Now this is your function. You're giving some input, you're getting some output. Now we'll see the definition, the proper definition of function, and we'll solve some questions related to the functions. So these are all functions, right? Fx is equal to 10. This is a constant function, no variable is there. You understand the difference between variable and constant, right? Variable is the value that changes. Here x is a variable because we can give different values of variable. We can put x is equal to 1, we can put x is equal to 0, minus 1, so value changes. Constant, 10 is a constant because it is a fixed value, right? So fx is equal to 7x plus 10 is a function of x. Why? Because the input value would be x. X square plus 5x plus 9, this is another function of x because the variable is x. So we are denoting it as fx, right? You can give different names also. So functions have different names. So like this is fx, there could be another function in x called gx. So let's say this is x cube minus 2x plus 1. This is another function. Here the variable is x, therefore in bracket you have x, and g is the name of the function, right? Okay. Another important characteristic of function is that it can be graphed. We can create a graph of every function, right? Okay. Yet another important property of function is that it gives only one output. For every function you will get only one output. So this is an important criteria. If any function is giving two output, then that is not a function. If any expression, any equation is giving you two outputs, then it is not a function. Okay. So let's see. So naming of function. So x square plus 5, this is a function in x. So where x is the input. X is the input, right? So in this case, our input is called x. We can call anything as input. It could be a function in k also. So now this could be function in k is equal to k square minus 2. This is another function, right? So where now here input is k. Okay. So what are ordered pair? Now ordered pair is when you mention the input and output. Ordered pair is when you mention the input and the output. Say for example, let's take this function for example. Here let's say you take any input or any value of x. Let's say you take x is equal to 0. What value of fx would you get? So fx would be 0 square is 0 plus 5. Fx would be equal to 5 in this function. So here 0, 5 would be one ordered pair. 0, 5 is one ordered pair. If you take x is equal to 1, what value of fx would you get? X is equal to 1. So 1 square plus 5. 1 square is 1 plus 5 is 6. If you take x equal to 1, you get fx is equal to 6. So 1, 6 is another ordered pair, right? Just like in coordinate geometry, we put the value of x and y, right? So those are also called ordered pair, right? So therefore it is mentioned that ordered pair, they also acts as coordinates. So we can use them to graph our function. Once we know all the ordered pair, we can plot these points on the xy axis and draw a graph. Okay, now different types of functions. Linear function is simply a line. See, we've seen different equations, we've solved different questions on in the coordinate geometry chapter related to linear functions. So y is equal to mx plus c, remember, where m is the slope and c is the y-intercept. This was equation of a line, right? So this is a linear function. Now why it is called a linear function? Because x would have power 1. If x has power 2, so say for example y is equal to x square plus 2 or something, then this is a quadratic function because x has power 2. This function, for example, is also a linear function. Why? Because x has power 1, 2x plus 1, right? Okay, now another reason why it is called a linear function is that if you make the ordered pair, that you take different values of x and different values of fx, as a result you'll get some points, right? If you put x is equal to 0, you'll get 1, y is equal to 1. If you put x is equal to 1, 2 into 1, 2 plus 1, 3. If you take x is equal to 2 into 3, 2 into 3 is 6 plus 1, 7. So 3, 7. Different ordered pair. If you plot these, you'll get a line, and that's why these functions are called linear functions. They are functions where variable has power 1. Quadratic function, or these are generally parabola. So we've seen different equations of parabola, and we've studied translation of graph. So where you studied that this is the function y is equal to x square. Remember, y is equal to x square, we had studied the equation of parabola. Now this is point of vertex. Now this is a quadratic function. Why? Because x has power 2. Now this is very important to understand vertical line test. Vertical line test says that if a graph of a function is given, you draw a vertical line, and if that vertical line cuts the graph at more than one point, then it is not a function. Function should be cut only at one point. Say for example, look at this. These are different equations, different functions have been given, different functions have been graphed. This is, let's say, function number 1, this is function number 2, this is function number 3. Now which out of these three functions is or are actually a function? For that we have vertical line test. The vertical line test says draw a vertical line anywhere in the graph. It should cut the function only at one point. If it cuts the function at more than one point, then it is not a function. So this one is a function. Is the first graph a function? No. If you draw a vertical line, it cuts at 3 points over here. It should only cut at 1 point. So this is not a function. Similarly, look at this graph. Is it a function? No. Draw a vertical line, it would cut function at 2 points. This is not a function, right? So this is called vertical line test. You draw a vertical line, it should intersect curve at not more than 1 point. It should intersect the curve, it should cut the curve only at 1 point, then it is a function. That's a vertical line test. Okay, we'll study nested function in a moment. So nested function is this. The notation is given as f of fx. F of fx. We're talking about the nested functions. Now what is this? So, or f of gx. These are various notations of nested functions. We'll try and understand this. Let's say there are two functions, okay? Fx is one function and gx is another function, right? Okay. Now let's say fx is a square function, okay, and gx is let's say a double function 2x, and we need to find out f of gx. Now what would this be equal to? First we need to find out f of gx. So what do we have to do is, instead of x, we talk about function f, which is a square function, right? We talk about function f, which is a square function, just that in the input, instead of x, the input should be gx. So what would that function look like? This is what we have to find, right? So the function is square function. We have to find out f function, which is a square function, and in the input it should be gx, not x. Input should not be x, it should be gx. And what is gx? Gx is 2x. So this gives us 2x whole square, which is 4x square. So f of gx would be 4x square. Similarly, can you calculate g of fx? Now we talk about the g function, which is a twice function, double function. So 2 times the input, and instead of taking input as x, we'll take input as fx, because what is there in the bracket, that is the input, right? So we'll take input as fx. So what is fx? Fx is x square function. Fx is simply x square. So this comes out to be 2 into x square. 2x square is the value of g of fx. So this is how we calculate nested function within function, right? Just you need to understand the concept of input output. It's super easy.